Guys, welcome back. Today I'm going to work on questions 11 through 20 of your study guide. So let's get started. Number 11 says Mindy sketched a graph based on key features. She knows that as x goes to positive infinity, as x is going this way, the y's are going down to negative infinity, and the function has a y-intercept at 0, 7. What other key features did she use to sketch the graph? So it says that as x goes to negative infinity, y is going down to negative infinity. We know that's not true. That it has an x-intercept at negative 14, 0. That's not true. The function is linear. Well, we can see that yes, it does form a straight line. But let's check the last one. That x increases for values of x such that x is between 7 and 14. We can see that that's not true because for values of x between 7 and 14 is going down. So that leaves my only correct answer to be C. All right, so we're going to move right along to the next question. Number 12, complete the key feature for the function in the graph. It says the graph is increasing when, where is it increasing? Well, looking here, it's increasing on this side. So it looks like it starts increasing really about right here. So, and that's negative 0.5. So that's looking for the x value. So it's increasing when x is greater than negative 0.5. Moving on to question 13, we're just buzzing right along. Use the table for f of x and the graph of g of x to compare the two linear functions. So I did this problem prior to creating this video, and what I did was I just kind of sketched this on top of this so that I could see. So if I go over here, negative 3 up 6, it's just to the left of this graph a little bit, and then my slope ends up going down 3 over 1, down 3 over 1. So I can see that this graph is decreasing more rapidly. So if I keep on going, the y-intercept was right here. So it says which one has a greater y-intercept? Well, that's going to be this one, because it's higher, it's greater. So f of x has a higher y-intercept. This is the graph of g of x. Which one has a greater x-intercept? Well, again, my x-intercept was right here, so it's just a little to the right of that one. So it also has f of x also has a greater x-intercept. And we can see that f of x is decreasing more slowly because it's going down like this. So this one is decreasing more rapidly. This is g of x, so f of x was going down more slowly. F of x decreases more slowly than g of x. And number 14. Select the graph of y equals negative 2x plus 3. So we're looking for a y-intercept of positive 3 and a slope of negative 2. So I can automatically rule out A, and A because it does not have a slope of negative 2. Looks like all of these have a y-intercept of 3 except for D, so we can rule out D, which narrows it down to B or C. Now, how do I decide between each one? Well, looking at my slope is down 2 over 1. So let's check it out. Down 2 over 1, down 2 over 1. So it must be B. We'll double check, making sure this one goes down 1 over 2, so it has a slope of 1/2, so it can't be C. Number 15. Select the graph of x minus 3y is less than 4. Well, I converted this. I moved my x over to the other side. It's just more helpful for me to do it that way. We'll write on the screen here. And I'm going to move and turn my light back on, so hold on. Okay, so I converted this to negative 3y is less than negative x plus 4. Okay, now I want to get that y all by itself, so it's going to have a -3 divided by -3 divided by -3. If you guys remember the rule of inequalities, if I divide by a negative on both sides, I have to switch the sign. So I have y is greater than now a positive 1/3 x minus 4/3. So write that down somewhere. Y is greater than 1/3 x minus 1/4. So let's look at it. Which one has, or minus 4/3, which one has a graph that matches that equation? Okay, so first of all, I know that it's going to have to be a dashed line because this doesn't have an equal to underneath of it. So I can automatically rule out B and C, so narrowing my answer down to A or D. And it looks like these lines are the same, so the important thing is to figure out which one has the correct shading. Well, if you remember, we had to flip our sign because we divided both sides by a negative. So we're looking for the values of y that are greater than that. So this is values of y less than, they're below it. This is values of y greater than all the points on my line. So that has to be the correct answer here with D. All right, number 16. Packages of books sent by a shipping service must weigh no more than 70 pounds. So I know they need to be less than or equal to 70 pounds, right? If they can't be any more than that. If an average paperback book weighs 1 pound and an average hardcover weighs 2 pounds, which graph represents the number of paperback and hardcover books that can be put into a package? So looks like they decided to make hardcover my y. So 2y represents the weight of each hardcover book, and each paperback weighs 1 pound, so 1 times x, which is just x. So this amount here has to be less than or equal to 70. So I like looking at it with y by itself. We could plug in values and see which one makes sense, but I like to put it in slope-intercept form. So I have 2y is less than or equal to -1x plus 70. All I did was took this, moved it to the other side of the inequality. I did that by subtracting it from each side. Now I want to get y by itself, so I'm going to divide everything by 2. So I get y is less than or equal to a -1/2 x plus 35. So we're looking for a y-intercept of 35, so I can automatically rule out B and C. So remember, it's -1/2 x plus 35. I'm going to have to move this so I can scroll down. So we can rule out B and C because they have y-intercepts of 70 instead of 35. So then we have to decide which one of these is it. Is it A or is it D? So looking at this, it is A. This one drops way too quickly. It's not going down. Think about going down 10 over 20. It only goes down 10 over 10, down 10 over 10. Because my slope is a -1/2. So I'm looking at 10s and 20s because, 10 over 20 is 1/2. This goes down 10 over 20. So this has the correct slope. All right, moving on to number 17. Complete the piecewise defined function that represents the graph. So it says the function equals -2 if x is less than -2. And we can see for values of x, not including, but greater than -2, it equals this function over here. Notice I didn't put greater than or equal to because this is an open circle. We do not want to include this point, so it's x is greater than. Number 18. What are the domain and the range of the function? So I mentally kind of sketched these out in my head. We're looking at x is greater than 2, and it started up here at 5. 1, 2, 3, 4, 5. And then my slope was go up 1 over 2, up 1 over 2. So for values of x greater than 2, plug in a 2, I get 1. 1 plus 5 is 6. So over 2 up to 1, 2, 3, 4, 5, 6. And does it include? Nope. So it's open, and we can see that it's going to be going up like this. This is x squared if x is less than 2. So if I plug in a 1, 1 squared is 1. So we're going to have a circle here. Plug in 0. 0 squared is 0. Plug in -1. -1 squared is +1. So my function's going to look something like this. So, says domain is all real numbers. Well, that's not true because notice these are both open circles here on 2. This should be a closed dot, and this should have started on 2 because notice it said less than 2. So we start on 2 but don't include it. So when I plug in a 2, 2 squared is 4. So 1, 2, 3, 4. We need to include that point here, but not a closed circle. It's an open one. This should be closed because it does include 1. Okay, so here's my graph. I had to make some adjustments here. So it says all real numbers for A and B. I'm going to automatically rule those out because it's not all real numbers. There's no value of x equals 2. Ever. Look at this. X cannot be 2. So it's got to be C or D. So then we got to look at our range. This range says all real numbers. So we can rule that out because we can see that ours is not going to be all real numbers. It's nothing. There's nothing down here. There's no graph. So my range cannot be all real numbers. This is going up this way. This one's going up forever this direction. So it's never ever going to be down here in my negative values for y. So my correct answer has to be D. Okay, number 19. True or false? A step function is a type of piecewise defined function. Well, that's true. It consists of horizontal segments. That's true. Piecewise is, or a step function has little pieces that look like steps. It's horizontal segments. Therefore, it is part of a piecewise because it's little pieces broken up. So this is a true statement. And last question of the day, number 20. If it ever decides to load, yay. Love technology when it moves slowly. Okay, it says, what is the range of the step function? So we're looking for the y values. Well, I can see for here, my y value is 0. For this little step, my y value is 2. For this step, my y value is 4, 6, 8. So 0, 2, 4, 6, and 8 are my y values for this function, so that is my range. And that's where we're going to stop. I hope so far this is making sense. If not, please shoot me an email and let me know so I can try to explain maybe a little differently or a little better.